Good morning, everyone, and thanks for the opportunity to present some of the work in the digital twin space across Victoria. Today, I will highlight some of this work being led through the Victorian Government. This short talk will be divided into three segments. I'll start with an overview of digital twins and the associated opportunities and challenges, then move to the main segment being a deep dive into the government use case centred approach to digital twins, and I'll wrap up by discussing forthcoming work and provide some brief thoughts on the digital twin roadmap. As a 10-minute snapshot, there is much that won't be covered, so feel free to reach out via email or through social channels. So let's get started. With many people online potentially being new to the concept of digital twins, I'll very briefly provide a framework of presenting our digital twin work. In most simple terms, a digital twin is a digital replica of the real world. Whilst there are many definitions of a digital twin, when we think of them as spatial digital twins, and especially over a precinct, municipality, or even a state, we can better understand the versatility of digital twins. The level of digital replication can vary, with a digital twin, for example, a bridge, may have sensors for deformation, traffic flow, etc., whereas other features such as a building may be limited to a three-dimensional model at a particular epoch in time. The cost of creating the exact digital replica of the built and natural environment that can measure all changes and interactions is currently prohibitive. And this is a key reason Victoria and many other jurisdictions take a use case approach. Rapidly decreasing costs in the capture of three-dimensional data in the Internet of Things has enabled governments from around the world to actively pursue spatial digital twins. However, as we all know, our cities are incredibly complex. When technology such as space-based imagery and artificial intelligence evolve, it is clear that 4D replicas of our cities will be much more powerful than they are today. Obviously, establishing spatial digital twins is not just about technology, data and algorithms, it's also about security, privacy, transparency, and obviously return on investment. State government has a really important role, particularly as custodians of such rich foundational data sets to support the use of spatial digital twins. However, we can't just go off and buy a digital twin. We can use the software, but it's really through collaboration and sharing of data and processes that a powerful digital twin that allows the real and digital worlds to interact together for it to be established. We have a really strong focus on the ecosystem of digital twins. This means that, the interoperability of data governance, and the need to support multiple digital twins. A significant piece of work critical to digital twins is the commitment to add building and utilities data to the foundational data sets, as per UN GGIM recommendation. Whilst I'm proud to present some of the amazing digital twin work today, it must be acknowledged that there is still a degree of discovery and learning being undertaken, especially across areas such as data formats and artificial intelligence. Most importantly, the Victorian Government is committed to working collaboratively with Australian jurisdictions to ensure that together our communities and cities can be global leaders in the use of spatial digital twins. Today, I'll share with you some of the early work in this use case-based journey. Obviously, there are many digital twin projects across the VPS and local government, utilities, academia, and obviously the private sector. Presented here is just a snapshot. Feel free to make contact to share your work or learn more about some of the other important digital twin projects happening across Victoria. Fisherman's Bend was the first significant digital twin project undertaken by the Victorian Government. And it was undertaken as a proof of concept to explore the utilisation of 4D data analysis and visualisation tools in the context of a large-scale urban renewal project covering around 480 hectares in the heart of Melbourne. In other words, it was a perfect canvas to learn about the functional delivery of complex digital twins in a real-world context. The bespoke spatial digital twin of Fisherman's Bend was produced on a platform that had years of development and research by our project partners, CS Stiller from the University of Melbourne. The digital twin essentially had three components, the first being general functions for a four-dimensional web-based mapping tool, such as navigation, searches, feature editing, queries, and so on. The second and most significant being the data registration and data utilisation within a 3D environment, including 2D VicMap data, 2D image mosaics, 3D image meshes, BIM data, and so forth. The third being, and potentially the the component that could be expanded even further is the various tools and analytical models that are employed. So things like time sliders and quantitative shadow analysis, sky view factors, these are the things that really power a digital twin. Lastly, it's important to note that the Fisherman's Bend Digital Twin is also a project showcase of other brilliant initiatives being done across the state government, including early artificial intelligence studies, the digital cadastre modernisation program, 3D capture, and obviously the presentation of some of the historic imagery that's been captured over decades. As mentioned, the Fisherman's Bend project was a major data aggregation exercise, namely including the BICMAP foundational data layers, imagery, textured, untextured building models, BIM files, and real-time data such as tram locations and the like, CCTV footage. Of course, these data sets can be utilised to undertake high-level planning assessments and investigations, which is really why the Fisherman's Bend digital twin was developed. Shown here are a variety of complex data sets ranging from BIM to live transport, as well as some of the key functions that come alive when using 4D digital twins. The 3D trees that you see here were captured by our BICMAP team when they were researching the use of machine learning for vegetation capture. As mentioned, DELWP is deploying a range of spatial digital twins. One of the newer projects is a cross-government rules-as-code project. In simplistic terms, rules-as-code involves converting legislation and regulations into machine readable code. In this instance, we used the Small Light Housing Code. Focused on our pilot site at Cairnlea within the Brimbank City Council, the project will see the development of a web-based tool which will allow users to input housing designs in BIM format. The rules engine will then consume contextual information such as the cadastre, roads, and the surrounding buildings to assess compliance with the Small Light Housing Code. It's a really exciting initiative that is at proof of concept stage at the moment, but something we feel is a real game changer with a whole range of different stakeholders. The last project I wanted to briefly outline is the work being done in the machine learning and AI space. The focus has been on building, vegetation, and swimming pool identification. As custodians of authoritative spatial data sets, high accuracy is paramount, and this has required substantial training sets to be created to enable the accurate capture of subject features when using machine learning, and this can vary across the state even. All future work in the digital twin space, not just for DELWP, but all users across Victoria will benefit from this type of work and the many projects presented today, including the cadastre modernisation, 3D capture, machine learning, historical image registration, and so forth. There is little doubt that the digital twin space is incredibly promising and exciting. At DELWP, we are moving quickly to bring this vision to life. So what are we currently focused on? The team continue to deliver updates to the Fisherman's Bend digital twin work and are starting to work quite heavily on the Rules-as-Code Cairnlea digital twin. The current focus is on Cairnlea, but plans exist to continue this work in a slightly different site in Hyde. The work is also informing how broader digital twins will be rolled across Victoria. Our projects focused on BICMAP, especially 3D and BIM files, are critical in terms of using data standards for enabling a range of other digital twin work to be undertaken. My role as the digital twin strategic lead will drive this vision and roadmap of digital twin adoption across Victoria, and that will continue to apply a use case approach. Many of these projects bring new discoveries, and as our knowledge grows and products mature, it's enabling various parts of government to better understand and action needs across policy development, governance structures, and data standard adoptions. To learn more about what DELWP is doing in the digital twin space, here are my contact details. Thanks for listening and enjoy the rest of the virtual conference, and I look forward to hearing from you all shortly. Thank you.